This is Precalculus video lecture number 3 on lines. This video is meant to be a review on graphing lines, writing equations of lines for a pre-calculus student. So if you need a more in-depth lecture, if you're an algebra student, then go to the algebra playlist to find a video that will break things down in more detail. So if you'll recall, the slope of a line passing through 2 points with coordinates x1, y1, and x2, y2 is given by the following equation or formula. We have m, that stands for slope, is equal to y2 minus y1 over x2 minus x1. And you could think of that as change in y over change in x, which we represent with a delta in math, change in y over change in x. And the change in the y direction is referred to sometimes as the rise, and the change in the x direction is referred to as the run. So let's look at some examples here. We're going to plot the points and then find the slope of the line passing through them and graph the line. So to begin, let's just go ahead and plot the points on our coordinate axes. Make sure you label everything nicely. So we have the 2 points 4, 2 and negative 2, 3. Okay, so here's my x-axis, y-axis, always label that 1, 2, 3, 4, 2, and then negative 2, 3. Okay, so here's 4, 2, here's negative 2, 3. I'll go ahead and plot or graph the line that goes through those 2 points. And then now let's go ahead and figure out what the slope is. Now, the only way you'll mess this up is if you forget the formula or if you plug in the coordinates into the wrong place. So if you tend to do that, then just underneath each of the coordinates label x1, y1, x2, y2. It doesn't matter which is which, but just to help keep things straight, this is optional. So m is going to equal y2 minus y1, so 3 minus 2 over x2 minus x1, so negative 2 minus 4. So I'm going to have a 1 over negative 6, which we write as negative 1/6. Don't leave the negative in the denominator, okay? Good. Let's look at this next example here. We have 2 points, negative 1, 3, and 4, 3. All right, let's go ahead and plot them. Negative 1, 1, 2, 3, there's 4. X-axis, y-axis, 1, 2, 3. All right, so here's negative 1, 3, here's 4, 3. Very good. Don't forget to put arrows on your line. Now, what do you notice about this line? It's different than the last one in the sense that it's horizontal, right? It's flat. Okay, well, let's see what its slope is going to be. Remember, we have y2 minus y1, so 3 minus 3, divided by x2 minus x1, that's 4 minus negative 1. So I'm going to have 0 divided by 5, which is 0. So the slope of this line is 0. All horizontal lines have a slope of 0. Okay? Now, this is different than if you had a vertical line. When you have a vertical line, the quantity in the denominator is 0, because basically you would have a run of 0, and then you have some number up here. So in that case, you'll either say that there's no slope or the slope is undefined. Okay? Now, don't get them mixed up. So here's what I think of. When you have a horizontal line, it's totally flat, and the slope is 0. Like when you're on a treadmill and you set the incline to 0, right? It's totally flat. So that's what a horizontal line is. Vertical line, different scenario. Okay, now there's 3 main different forms that we use to write the equation of a line, and here they are. First one is slope or y-intercept form, y equals mx plus b. This one's typically the best one if you need to graph. And usually if you're asked for the equation of a line, this is the final form that you want to give it in. Okay, you want to isolate y. Then there's point slope form, y minus y1 equals m times x minus x1. This one is excellent to use anytime you're asked to find the equation of a line. So this is good for writing equations of lines. Notice the difference is that you can use any point x1, y1 that's on the line, where in slope-intercept form, b is specifically the y-intercept. So point slope form's super versatile. And then there's standard form ax plus by equals c, where a, b, and c are integers. And then depending on the textbook, most of them will require that a be positive, okay? Standard form, if they ask for standard form, write your final answer in standard form. It can be super useful if you need to find x and y intercepts. Okay, I'll show you how to do that pretty easily. Good, so let's look at some examples here. First one says, find the equation of the line with the given properties. So the slope of the line is 2, and it contains the point 4, -3. Well, they're asking me, find the equation of the line. So of the 3 forms that we looked at up above, if you're being asked to find the equation of a line, you want to jump to point slope form 99% of the time. Okay, now let's see, what did they give us? They gave me that the slope is 2, so that means m is 2. And then they've given me this point 4, -3. Well, that's what I'm going to use for x1, y1. So this is my x1, this is my y1. Okay, you leave y and x as variables in the equation. Those stay. Only the variables with subscripts, so only x1 and y1 get replaced with constants, and then you also replace m with whatever it is. Okay, so here we go. Put it all together. So we have y minus y1 is -3 equals m is 2 times x minus 4. Okay? And then now the worst is over. We just got to clean this thing up. So we have y plus 3 equals 2x minus 8. So y equals 2x minus 11. So once you've isolated y, once you've written the equation in slope-intercept form, you're done. Okay, and the cool thing is now I know actually that the y-intercept is where? Can you tell? Look at the equation. This is b. -11 is b. So that means the y-intercept has coordinates 0, -11. So if it's an intercept, remember, like we went over in the previous lesson, you always have to write it as an ordered pair. Okay, beautiful. Let's move on to another example. Same direction. So find the equation of the line that contains the following 2 points. Okay, so the directions are the same. Find the equation of the line. So probably we're going to use point slope form, y minus y1 equals m times x minus x1. And now ask yourself, what is different about the information I'm given here compared to the previous example that we just did? Do you notice what's different? Well, they didn't give me the slope, but instead they gave me 2 points that were on the line, not just 1. So that's not a problem. What we can do is we can go ahead and find the slope ourselves since we have 2 points. So here we go. So y2, 5 minus 4 over x2 minus x1, so 2 minus -3, so that's 1/5. Okay, very good. So that's the slope that I'm going to use. That's m. And then now which point should we use? -3, 4 or 2, 5? Guess what? It doesn't matter. Do whatever you want. I'm going to go with 2, 5 just because I feel like it. So here we go. So I'm going to have y minus 5 equals m is 1/5 times x minus 2. All right, and then let's go ahead, distribute, clean up. So we've got y minus 5 equals 1/5 x minus 2/5. And then adding 5, so if I add 5, let's see here, I'm adding 25 over 5, yes? So y equals 1/5 x plus 23/5. And guess what? I'll let you do the same problem again with -3, 4 and make sure you get the same thing. So the y-intercept is 23/5. You should verify that, just so you believe it in your heart. Okay, let's look at a few more scenarios. This one here says the x-intercept is -4 and the y-intercept is 4. Well, naughty, naughty, they should have written those as ordered pairs, right? If the x-intercept is -4, that means the point -4, 0 is on the line. And if the y-intercept is 4, then that means the point 0, 4 is on the line. So what would you do to start? Well, again, they gave us 2 points, 2 ordered pairs that are on the line. So let's go ahead and figure out what the slope is. So I'll have 4 minus 0, y2 minus y1, over x2 minus x1, so 0 minus -4, which gives me 4 over 4, which is 1. So slope is 1. Now, you could go to point slope form that we've been using, but actually in this particular problem, we can go straight to y equals mx plus b form. Why is that? Because they gave me b. They gave me the y-intercept. B is equal to 4. So you can go straight to y equals mx plus b, or y equals x plus 4. Okay. Now what if you didn't notice? You're on autopilot. You've been doing so much point slope form. Y minus y1 equals m times x minus x1. No big deal. Pick your favorite point. Say you used 0, 4. You would just have y minus 4 equals 1 times x minus 0. And then when you clean it up, you get y equals x plus 4. It just took you a little longer to get there. Okay? Nice. Now let's look at one more. Here the problem says the slope is undefined and it contains the point 4, 8. Okay, now remember, if the slope is undefined, that means we have a vertical line and it contains the point 4, 8. Well, how would you write the equation of this line? Well, can you think of another point that would be on this vertical line? Like, what would the coordinates of this point be, maybe? I didn't tell you exactly how much this distance is, but maybe something like 4, 2, or maybe 4, -10, right? So look at what's going on with this vertical line. Every single x coordinate for the points that are on the line is equal to 4, but the y coordinates can be any number. Y just runs wild. So to write the equation of the vertical line, I'm just going to state that x has to equal 4, and that's it. The x coordinate of every single point on the line is 4. Y is not involved in the equation. Y just runs wild. It's free. Okay, in fact, any vertical line in 2 space, you would write the equation as x equals 4. Now I have a question. What if instead the line was horizontal? And it went through the same point though. So we have this line, this time it's horizontal, not vertical, and it goes through 4, 8. Well, you might guess, oh, it should be y equals 8, because again, this point would be something like 10, 8, -2, 8, etc. But remember, the difference with horizontal lines is that they actually do have a slope. The slope is equal to 0. So if you were to use point slope form, because we were given 4, 8, right? And you did y minus y1 equals m times x minus x1. Well, this whole term just goes to 0. And then you would get, you move that 8 over, move it over there, you would get y equals 8. So that's the difference with horizontal and vertical lines. Because horizontal lines have a slope of 0, you can still use point slope form and be okay, but for vertical lines it doesn't work because there is no m. M is undefined. Okay, good. Now, just to recall, two lines are parallel if they have exactly the same slope, and then two lines are perpendicular if the product of their slopes is -1, or another way of saying that is the slope of one line is the negative or opposite reciprocal of the slope of the other line. So what exactly does that mean? Well, let me give you an example. Say I have the slope for one line and it's equal to +2/5. Okay? The slope of a line that's perpendicular to it would have the opposite sign, so it would be negative, and it would have to be its reciprocal, 5/2. So the slopes for these two lines would show that they're perpendicular. Now notice if I took the product of these two slopes, 2/5 and -5/2, you get -1. So that's where this definition comes from, that the product of their slopes is -1. So think about it. You have a slope m, and then the perpendicular slope would be -1/m. Well, m times -1/m is always -1. That's basically what it's saying. Okay, also some useful abbreviations, because why not? So this symbol we can use to represent the word perpendicular. Okay, and then if you have like two little dashes or tick marks like that, that's parallel. You've probably seen those maybe back in geometry days or something. Okay, so here we go. Find the equation of the line. So it sounds like we're going to be using some more point slope form, right? Find the equation of the line with the given properties. So first thing it says is that our line is parallel to the line y equals -3x plus 7. So what's the slope of our line going to be? Well, if it's parallel to this line, they're going to have the exact same slope. So the slope of our line is going to be -3. I do not care what the y-intercept is of that other line. Irrelevant. All I need to make sure now is that my line goes through the point -1, 2. Not a problem. I'm going to use point slope form. Y minus y1 equals m, which I now have, times x minus x1. And then this is my x1, this is my y1. So here we go. We've got y minus 2 equals -3 times x plus 1. So y minus 2 equals -3x minus 3. So y equals -3x minus 1. Beautiful. Okay. We'll just put a cloud around it. Good. Let's look at another example now, a little more advanced. This time we want the equation of the line that's perpendicular to x minus 2y equals -5, and it contains the point 1, 3. Okay, so remember, if our line is perpendicular to this line, then their slopes are going to be opposite reciprocals. However, the way this line is currently written, I can't tell what its slope is just by looking at it. So we have to rewrite it so it's in y equals mx plus b form. I have to rewrite it so it's in slope-intercept form. So let's isolate y. I have -2y equals -x minus 5. So then I'm going to divide everything by -2, so y equals 1/2 x plus 5/2. All right, good. So what is the slope of this line? The slope of this line is 1/2. So that means the slope of our line, which is perpendicular. So I'm going to put m with a little subscript perpendicular symbol to differentiate between the two slopes, right? Don't use the same variable if you have slope of one line, and don't use m again for slope of a different line. Our slope is going to equal, well, it's going to be negative, and then take the reciprocal of 1/2, 2. So our slope is -2. And then it goes through the point 1, 3. Okay, so here we go. Y minus y1 equals m times x minus x1. So we've got y minus 3 equals -2 times x minus 1. And then distribute. So we've got y minus 3 equals -2x plus 2. So y equals -2x plus 5. Good. That's probably as tricky as they're going to get. I'll be honest with you. Okay. Remember I told you standard form was nice for finding intercepts? Now you're going to see just how. So if you'll remember in the previous lesson, we looked at finding x and y intercepts, but not just for lines, for any kind of equation in two space. So remember, to find the x-intercept, you let y equals 0 and solve for x. Always plug in 0 for the opposite variable, whichever intercept you're not finding. And then to find the y-intercept, you let x equals 0 and solve for y. So here we go. We're going to find the intercepts of the following line and graph it. And once you have the intercepts, you can use them to graph. Okay? I'm going to show you a way you can do this with no work, because it's in standard form. Here you go. X-intercept, y-intercept. It's going to take 2 seconds. Maybe you already know how. So if you're finding the x-intercept, you're substituting in 0 for y, correct? So put your hand over the negative 2y, or just imagine it gone, because you're substituting in 0 for y. And all you're left with is the equation 3x equals 6, right? Can you solve that in your head? 3x equals 6, it would be x equals 2. So the x-intercept is 2, 0. See how snazzy standard form is? Okay, now let's try the same thing with the y-intercept. You just have to be a little bit careful because of this negative here, right? So imagine the 3x is gone because you plugged in 0 for x. So you have negative 2y equals 6, which means y is equal to negative 3. So we've got 0, negative 3. That's it, and then now you're ready to roll. So we can graph the line. I have these 2 lovely points. Okay, so x, y. X-intercept is at 2, 0. Y-intercept is at 0, negative 3. Beautiful. Don't forget your arrows. Good, good. All right, let's look at one more example here where it's a little trickier. So we'll still find the x and y intercepts, but we'll talk about what makes sense in terms of graphing right now, okay? So x-intercept, you're plugging in 0 for y, so imagine the 3y is gone. You just have 5x equals 18. So x-intercept is 18 over 5, comma 0. Now, other guy's turn. So y-intercept, imagine the 5x is gone. That means y is 6, so 0, 6. Okay. Now from here, you might say, ooh, I feel a little uncomfortable graphing 18/5, as you should. It's 3.6. Okay. If you want the absolute most perfect graph, though, it's probably not the best way to go. So, what to do? What to do? Well, remember, we could rearrange this equation and put it in slope-intercept form. So I would have 3y equals negative 5x plus 18, divide by 3, so y equals negative 5/3 x plus 6. So the slope of the line is negative 5/3, and it would be more precise to graph it using this method, using the y-intercept and then counting rise over run with the slope, so that you're not just eyeballing where 3.6 is, okay? So here's 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, I need a little more. Okay. One, 2, 3, 4, 5, 6. Okay, there's the y-intercept. 0, 6. Now you could plot 3.6. Just because I'm in a perfectionist mood, I'm gonna go down 5 and over 3. So go down 5 over 3. You're right here. Rise over run. And then, lo and behold, my goodness, we couldn't have done better if we tried. You see this point right here? There's our x-intercept. That's 3.6, isn't it not? That's 18/5, comma 0. Voila, I love it. I hope you do too. So this was just a light review, more fun to come, and stay tuned, we're going to be graphing circles in the next lesson.